Greetings to everyone. In today's video, we're going to be looking at solution to GCE Maths June 2021 questions 2. Now, question 2 says, given that the roots of the quadratic equation x squared plus bracket open 2k plus 2 bracket close x plus 2k plus 5 equal to 0 are alpha and beta. Find the value of the constant k for which alpha is equal to beta. 3 marks. Sub 2. For k greater than 0, find the quadratic equation whose integral coefficients, whose roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. 5 marks. So the entire question is 8 marks. And let's get into the video. Now we have been given our quadratic equation. And it is said here that alpha and beta are the roots of this equation. So alpha and beta are the roots. We know from here, we compare this with ax squared plus bx plus c equal to 0. This is the general equation of a quadratic. This is the general equation of a quadratic equation. And if we compare this, we know from here, we know sum of roots will be, sum of roots here is minus b all over a, which will be alpha plus beta, which will be minus b on a according to equation star. We name that equation star. Minus b on a according to equation star is minus b, our b is 2k plus 2. On a, our a is 1, so this is our b. So this is our b, this is our b, and this is our c. And 1 obviously is our a. Now we have been given that we just need to substitute our values. It means that we have our sum of roots. Therefore, our conclusion here is that the sum of root alpha plus beta is 2k plus 2. That is our equation 1. Now, the second condition, our product of roots, which can be written as alpha beta, which is c on a, is equal to c on a. Our c here is our c. Therefore, we have 2k plus 5 divided by our a is 1. So it means that our product of root, which is alpha beta, will be 2k plus 5. So this is our equation 2. Now our equation 2 clearly states alpha, but we have been told that alpha is equal to beta. Now the equation says alpha is equal to beta. Now we're going to use this knowledge or this idea to substitute in one of our equations and make and look for the value of k. So basically what I mean is, if we take this and we call this equation 3, and we say now equation 3 in equation 1, means anywhere we see alpha we're going to put beta, or anywhere we see beta we're going to put alpha. So I'm going to go with anywhere I see alpha I'm going to put beta, which means that if I continue here, now if I substitute, if I say equation 3 in equation 1, it means I'm going to have alpha plus, since we said alpha is equal to beta, I'm still going to have alpha here to be 2k plus 2. Now this is 2 alpha to be 2k plus 2, which means that if we further simplify, our alpha is equal to k plus 1. Now if we take equation 3 in equation 2, we're going to have, remember we're using alpha, it means we are going to use that all through. It means we are going to have alpha times alpha to be equals to 2k plus 5, which means that alpha squared should be 2k plus 5. Now we have been told that alpha squared is 2k plus 5. What do we know from here? We can call this our equation let me say equation double star, and we call this equation triple star. We see here that from double star, if we substitute anywhere we see alpha, we're going to keep k plus 1, since alpha is equal to k plus 1 and alpha squared here is equal to 2k plus 5. So means we're going to have k plus 1, all that squared, to be equal to 2k plus 5. Here we simply expand this function, so we do the normal expansion. This will be k squared plus 2k plus 1 to be equal to 2k plus 5. We see clearly that something is going to cancel out. We see 2k is going to cancel out, so it means that k squared will be equal to 5 minus 1. So sending 1 the other way, which means it will be 4. Therefore, k is plus or minus 2, taking the square root on both sides. Now we have used the idea or the statement that was stated in here to show that our k is plus or minus 2. The second part of the equation says that for k greater than 0, what does that mean? If they say k is greater than 0, it means that we know that our k is either 2 or our k is minus 2. But in between these two values, we have one that is less than 0. No, for k greater than 0, we have k to be 2. Now for k less than 0, we have k to be minus 2. It means that there are actually two values of k, a negative value and a positive one. But the second part clearly states that for the positive value of k, which is for k greater than 0, find the quadratic equation with integral coefficient whose roots are 2 alpha plus alpha beta, 2 alpha plus alpha beta, 2 alpha plus alpha beta, and 2 beta plus alpha beta. Now we need to work with that, but for k greater than, it was strictly greater than 0, for k greater than 0. So what we need to do here is we're going to take our k, it means our k is 2, and we substitute in our original equation. Substituting in our original equation, we know that our original equation was x squared plus 2k plus 2x, 2k plus 2x, 2k plus 2x plus 2k plus 5 plus 2k plus 5. Now this is our quadratic equation. Let's call it f of x. Now if we substitute for k equal to 2, it means we're going to have k squared, x squared plus k is 2, means we're going to substitute anywhere we see k will replace 2, so it will be 4 plus 2, which will be 6x. Now 2 times 2 will be 4 plus 5, so plus 4 plus 5 will definitely be 9. So this will be equal to our f of x. Now we have been asked to look for the quadratic equation whose integral coefficients are these. Now in this case, we're going to look for our sum of roots. The sum of roots will be alpha plus beta, as seen earlier, which is minus b on a, which will be minus 6 on a is 1. And our product of roots will be alpha beta, which will be c all over a, which will be 9. So we have this, we're going to call this equation star and equation double star. Now we have these two equations. We're going to say sum of new roots, which will be equal to, now our new roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. So this, when we sum these two, we're going to have 2 alpha plus alpha beta plus 2 beta plus alpha beta. Doing that, we're going to have 2 into alpha plus beta plus 2 alpha beta. We see clearly that here we have sum of roots, which clearly is negative 6, negative 6 plus 2 into product of roots. Our product of root is 9. So looking at that, we're going to have minus 12 here plus 18. So that will give us 6. Now, our product of new roots will be equal to, our new roots are 2 alpha plus alpha beta times 2 beta plus alpha beta. So expanding this, we're going to have, doing the normal expansion, we're going to have 4 alpha beta plus 2 alpha squared beta plus 2 alpha beta squared plus alpha beta, all that squared. Now that is a normal expansion. We notice that this and this look similar, but this is just 4 times the product of roots. So we're going to maintain this, so it will be 4 alpha beta. Here we see that something is common. First of all, 2 alpha beta is common. We'll be left with alpha there plus beta there. If we expand this function, we're going to come back with this. So plus alpha beta, all that squared. Here we see, we just simply need to substitute our value. We know that our product of root is 9. So this will simply be 4 times 9 plus 2 times 9 times our sum of roots is negative 6. So plus our product of root is 9. Now all that squared. So using your calculator to multiply that, we are going to have, our answer here is going to be 9. So we have our sum of new root to be 6, and we have our product of new root to be 9. Then forming our equation, because we were told that we need to form a quadratic equation whose integral coefficients are alpha plus beta. So we're told that we should form a quadratic equation whose integral coefficients are alpha and beta, 2 alpha plus alpha beta and 2 beta plus alpha beta. So generally the formula is given by x squared. The formula is given by x squared minus sum of new roots of x plus product of new roots equal to 0. So simply we're going to substitute this. It means we're going to have x squared minus our sum of new roots is 6, so it will be 6x now plus our product of roots is 9 equal to 0. So here is our quadratic equation whose integral roots are 2 alpha plus alpha beta and 2 beta plus alpha beta. So if you do that, you're going to have the 3 points as requested from the 8 points. If you're able to solve this, then you're going to have all your 8 points as stated by the equation. Now the sub part of this question, the B part of this question says that find the range of values of x for which 2 minus x divided by x plus 1 is greater than or equal to 0. 3 marks. So this is an inequality. We have been given an inequality to solve. Now the first remark that I want you all to take note of is you should never ever cross multiplication in inequalities. So we want to solve this inequality. You should never ever cross multiplication. You should never ever do this. Immediately you cross multiplication, you're going to cancel our solutions. So always make sure to look for your critical values. So we have 2 minus and x plus 1 to be greater than or equal to 0. The first thing you need to do when we have inequalities of this sort is to look for the critical values. The critical values. We simply equate a numerator to equal to 0 and a denominator equal to 0 to get a critical values. It means that we're going to take 2 minus x will be equal to 0, which implies that x will be 2 and x plus 1 equal to 0 implies that x will be equal to minus 1. Now after having our critical values, then we need to come up with a number line. Now the values that our critical values will be placed on the number line in increasing order. So we have -1 is going to come first, and then 2. It should be in increasing order, like a normal number line. So if we had a value like -3, therefore obviously the -3 would appear here. Or if you had a value like 4, therefore the 4 appear there. Now our critical values separate our number line into 3 regions. This is the first region for all x greater than 2. This is the second region for all the values in between -1 and 2, and this is the third region for all the values less than -1. Remember, we're dealing with inequalities, and when it comes to inequalities, we're dealing with a range of values. If it is an equality, therefore we're dealing with just a single value. Now, looking at these values, we're going to take for each of the region, consider what the sign will look like. So if we consider let's look for this region. We're going to take a random value in this region, let's say 0, and make sure to always take a value that will simplify your work. If you take a value that is going to cause you to calculate a lot, you might likely make a mistake. So it's always good to take values like 0 so that I can do the computation very easily. So if you take a value, let's say 0 here, and we substitute it in this our original inequality, we're interested in the sign of the inequality. Remember, we're taking a range of values depending on the sign of our inequality. So if we put 0 here, we're going to have 2 in the numerator, and we put 0 down, we're going to have 1 in the denominator. This is positive, so this is positive. So here we have plus 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 plus. Now we're going to take a value above 2 or greater than 2. Obviously, let's take 3. So if you take 3, we're going to have 2 minus 3 will be -1, and 3 plus 1 will be 4. This is a negative value, so we have negative, negative, negative. And if you take a value, let's say -2 down, we are going to have 2 into negative, -2, which is going to give us positive. Now divided by -2 plus 1. We're going to take a value, let's say -2. -2, if we put -2 there, we're going to have, so this will be negative. So -2 plus 1 will be -1. So this will be negative. So normally, once you place your values on a number line in increasing order, and there is no square in our original equation, and there is no square here, therefore once you get the if the first region, you can simply take the opposite. So if we had another region, here will be plus plus plus, and here will be plus plus plus. If we had another region, it will be minus minus minus. So what I'm trying to explain here is once you place these values in increasing order, they will always sort themselves out in this pattern: plus minus plus minus plus minus plus minus, all true. So after coming up with this, we can now after coming out this number line, it has indicated the signs of our inequality. Therefore, we have to compare this with our original value. Comparing this, our original equation says that the values for this inequality to be greater than 0. When we talk of greater than 0, we mean that the value should be positive, and for positive, we're in this region. Therefore, the solution to this equation, or the range of values for which this inequality is greater than or equal to 0, is x less than or equal to 2 and greater than -1. Now I want to point out something. Now if we look at this function, we see that the domain of this function belongs to the set of R minus -1. Why? So if we put -1 in this our function, the function itself will not exist, because the denominator, a number divided by its by 0, does not exist. So it's always good to point out the domain of your function, so that you should not make a mistake. So if we look at this our inequality here, it is strictly less than, not less than or equal to. The reason being that if we put less than or equal to 1, then this function will not exist, therefore this will be wrong. But if you take your domain and you know that 1 is not part of the solution, you're going to avoid this mistake. This kind of questions are very common in MCQ, so always watch out. Always watch out to these small mistakes, not to fall into the trap. So that's all for the video. If you found the video helpful, consider subscribing and turning the bell notification, so that whenever I upload new videos, you are going to see it. And I'll be uploading more videos in other subjects like chemistry, mathematics, further maths mechanics, further maths mechanics, physics mechanics, and all, even MCQs, even for ordinary levels. So if you see that these videos are helpful, try share it with your mates, so that we can reach a larger audience. You can also like the video, so that you can support as a form of supporting, and put in the comment section any question or any topic you want us to make a video on. Well, we'll gladly and happily do that. So see you all in the next video.